Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 6.1 and 6.2, solving and graphing solutions to inequalities. So hopefully you should find this mostly review. If not, you'll want to come in and see me if you're having some trouble with it. All right, number 1 on our warm-up. Match each exercise with the label A, B, or C. So first one, we're trying to get an expression, equation, or inequality. So I'm going to work backwards. So an expression is formed by variables, numbers, and operators put together. And that's it. So this is the only one that has only variables, operators, and numbers. So this is a variable for x, a number 2, and then we have the operator subtract in between it. The other two have inequality or equal signs between them. So the equal one is our equation. This is formed by an expression on each side with an equals in between. Okay, that's what makes it an equation. And an inequality is formed with an expression on either side. So there's first expression, there's the other expression, with an unequal sign in between. In this case, we have less than. These two sides are not equal. The left side is smaller than the right side. Okay. All right, number 2, solve each equation. So in this one, this is a two-step equation. So we add 5 to both sides to get 10. And then we divide both sides by 3, and we can write this as either a decimal or a fraction, and I'm going to go with a recurring decimal this time. So this will be 3.3 with a bar. Number 3, two-step equation again. So we add 10 to both sides to get 18. And then we're going to times both sides by -7. So I'll get the calculator out here, and I'm doing 18 times -7. So it'll be -126. Okay. Number 4, graph the solution set for each inequality. So what we're trying to do is think of all x's that make the statement x greater than or equal to 0 be true. Okay. So greater than or equal to 0 means x could be greater, or x could also be equal. So both of these statements make it true. Okay. So in this case, equal to 0. I'm going to put my boundary point here, and we're going to fill it in because x is allowed to be equal to 0. And then we can also have x's that are bigger than 0. The things that are bigger than 0 are 1 and 2 and 3 and 4 and all the decimals in between. So all of these points shaded out towards 5 and on past 5 are all the things that are bigger than 0. So for instance, if I picked a point on anywhere in this shaded area, like 4, I could plug that in for x, and this would be a true statement. Okay. All right, so for number 5, this says -2 is either greater than x or -2 is equal to x. So anything that makes these two statements true, I'll shade in. So that means I should shade in -2 because -2 is equal to x. And then it also says -2 is bigger than all the x's. So -2 is bigger than which numbers? Well, -2 is bigger than -3 and -4 and -5 and -6. Okay. So to test myself, I always pick a point in the shaded area, like -4 here, and I plug it in just to make sure that this is a true statement. And I would much rather owe $2 than owe $4, so -2 is bigger. Second page, solving inequalities. Solving inequalities is done with the same step-by-step processes that we use to solve equations. However, there's one key difference. Sometimes the inequality sign, less than, greater than, less than equal to, greater than equal to, must switch directions. Okay? So let's get the reason why, and then we'll go back and look at an example. So we need to switch the inequality sign when we multiply or divide each side of an inequality by a negative number. Okay? So this means when we do our inverse operation, we times both sides by -2, or we divide both sides by -0.5, then we have to flip the inequality sign. Let's see if we can see why. So we say 10 is definitely bigger than -20. I'd much rather have $10 than -20. I'm going to times both sides by -2. So times by -2. This will give me -20 on the left side and +40 on the right side. So you can see timesing by a negative changes the signs, and we have to change the inequality sign also to keep it still be a true statement. So 40 is definitely bigger than negative 20, so I need to change the greater than here to a less than to keep the statement to be true. Okay? All right, so that's the only little trick. Everything else works exactly the same. So let's solve a couple. First one, we're going to divide both sides by negative 2. Well, we just learned that if we divide both sides by a negative, we have to flip the inequality. So we'll change it from greater to less than. Okay, that means our circle goes on negative 5, and we want to graph everything that is smaller than negative 5, so our line's going to go this way. And you might say, well, why didn't you fill in the circle this time? So remember, when it's less than, like this, we don't fill it in because the less than is not equal to. It's just less than. So negative 5 is not one of our answers. If I try to plug negative 5 in here, I don't get a true statement. This is false. Negative 5 is not smaller than itself. So that's bad. So what I have to do is put an open circle here. And the reason I put an open circle is I can get as close to negative 5 as I want, but I can never quite get to it. So negative 5.000001 is a solution, but how do I graph negative 5.001 without making it look like negative 5 is also a solution? And the trick is to put that open circle. Okay. Number 2, we're going to divide both sides by 5. So I'll show my inverse operation again. This will say x is greater than or equal to 2. Notice I did not flip this time because I divided by a positive number. So I put my circle on 2. It's filled in this time because of the equal to bar, because 2 is one of my answers. And this says 2 is smaller than x. So that means all my x's are bigger than 2. So I shade this way. So my circle on 2, and I shade to the right. Number 3, first thing I'm going to do is my distributive property. So I'm going to get negative 2x plus 6 is less than negative 4. And then I'll solve my two-step equation. So negative 2x is less than negative 10, and then divide both sides by negative 2. And that's going to flip my inequality. So my circle is going to go on 5. And we're going to shade to the right. And once again, I did not fill in the circle because there is no bar for equal. It's only greater than 5. Number 4, I'll combine my x's together first to get negative 3x is less than negative 12. I'll divide both sides by negative 3. This will give me x is greater than 4. I flip the inequality this time because I'm dividing by a negative number. Okay, so my circle is going to go on 4. It's not filled in because we don't have an equal to bar. We just have greater. And then it says x is greater than 4. So x is all the numbers bigger than 4. So that's like 5 and 6 and 7. Okay, so there's our circle. And we shade to the right. Now our last two questions here. We get all the x's on the same side first, so I'll do minus 2x. I like to keep my x's positive if I can. So this is negative 18 greater than 6x minus 6. And then I'll add 6 to both sides. This will give me negative 12 is greater than 6x. And then I'm going to divide through by 6. So this will give me negative 2. Now this is a place where some people think, oh, you should flip the inequality because we had a negative. We divide it through. We still get a negative here. But what we divide by, well, we divide it by a positive 6. So even though a negative 12 is already there, it's what we divide it by to both sides. So it doesn't flip. Therefore, I put my circle on negative 2. Okay. It's filled in this time because of the equal to bar. And then it says 2 is bigger than x. So 2 is bigger than all of the answers. These are the numbers that negative 2 is bigger than. Negative 2 is bigger than negative 3, negative 4, and negative 5, etc. All right, our last one. First, I distribute. I get 6x minus 3 is less than or equal to 18 plus 6x. I get all my x's on the same side. So let's see, if I subtract 6x to both sides, I get left with negative 3 is less than or equal to 18. All right, well, where did all the x's go? They're gone. So this is a special one. When you are done solving it, if what's left is a true statement, that means everything works. If what's left is a false statement, then nothing works. So is negative 3 less than 18? Oh, yeah, it is. So all solutions work. So So we would shade in everything, and our answer here is all real numbers. Just like it was when we solved and we found out an equals to statement that was true. All right, so you should begin a Khan Academy coach's recommendation on two-step inequalities. It will be due the day after our next class. So you're doing this and coming back to class, and then it's due the next time, so you get some chance to practice. The Khan Academy one is only two-step inequality, so it doesn't have quite the harder ones we did on the bottom here for 5 and 6.